Hi, everyone. Thanks for joining us for Programmers Week. For those of you who don't know me, I'm Nihal. I've been with Cognizant Softvision since early this year. I mostly work on web apps and the technology stack
Recording in progress.
Like microservices, chatbots, and sometimes blockchain. And I'm really excited to talk about blockchain today and its utility in the enterprise. I encourage everyone to share your questions in the chat module so I can answer them accordingly. So without further ado, let us get started. So this is what we are going to cover today. We are going to start with a basic overview of what a blockchain is. And then we would cover the categories of blockchain later on in the discussion. We would have a look at the ecosystem revolving around the blockchain technologies, the various different things that we hear about in the day-to-day life. We are also going to have a look at innovative application and opportunities that arise out of blockchain area. We are going to have a look at the consensus algorithms, because of which people call blockchain a democratic system. We are going to have a look at the available technologies and frameworks in enterprise blockchain landscape. We are going to see who the major players are. And we are going to see some industry implementations as well. And then towards the end of this discussion, we will look at the possibility if we can basically have a look at some DIY stuff. Now, blockchain is a vast area. In the last 5 or 6 years alone, more than 100 different subtopics or sub areas have grown out of it. And it is not possible in this discussion of about an hour to discuss everything. We are going to touch some of those topics, not all of them today. So first of all, let us understand what a blockchain is. Now, essentially, blockchain is a database. And it offers some features that makes it different from other databases, the normal ones. Blockchain is a decentralized, shared, immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. An asset can be a tangible asset, like a house or cash. It can be an intangible asset, like intellectual property, copyright, or a piece of art, or a brand logo, or something like that. Virtually anything of value can be tracked and traded on a blockchain network. And the benefit it offers is reducing risk and cutting costs for all the parties involved. Different types of information can be stored in the blockchain, but the most common use case that people have seen so far are of the financial transactions in the form of cryptocurrencies, for example. In Bitcoin's case, for example, blockchain is used in a decentralized way so that no single person or group has control. Rather, all users collectively retain the control. So it basically becomes decentralized. Now, decentralized differs from a normal system. A normal IT or software system would be controlled by one party. On the other hand, decentralized one is generally something that is controlled by a group of people or nodes. They're called peers in a network. Now, some of the main features that blockchain offers are it is decentralized or distributed. The ledger is replicated in a distributed fashion. This facilitates the absence of an intermediary or controller. This basically facilitates the absence of a middleman. So you don't have to depend on a middleman in order to carry out a transaction. It is democratic in nature. Whenever something is going to be written to the database, it is going to be written with everybody's consensus in place, everybody's voting in place, just the way it happens in a real democracy in real life. You vote, and the collective decision of all the people, the majority, where the majority goes, is taken into consideration. That's the same thing that happens when something is committed to a blockchain database. Now, blockchain is immutable. What it means is, once something is written to blockchain, it cannot be altered deliberately or by a bad player. The way it happens is, blockchain is basically, the information that is stored in blockchain is basically stored in a block by block fashion, where each block is connected to the previous blocks, the chain of previous blocks. And there is something called as a previous hash and a current hash. And hash is nothing but a mathematical way of generating a signature of data that is passed into it. So with the help of the hashing, the data in the blockchain remains consistent. It cannot be altered. It cannot be played with. Because of this, blockchain offers another quality, which is called as it being the single source of truth in systems. So when blockchain is in picture, it acts as a single source of truth. All the parties involved in the network would basically rely on this data and can, without basically trusting on anybody, unlike in centralized systems, it can rely on this one source of data that is telling it the state of the data at a point in time. Now, one of the other features that blockchain offers, apart from all the others that we discussed, is transparency. Now, blockchain was originally meant to be a public network, wherein all the parties involved would be able to see each other's transaction. So essentially, the original blockchain, which basically originates from Bitcoin, is 100% public and is transparent. I mean, when somebody is doing transaction on blockchain, Bitcoin blockchain, you'll be able to see what has been done. It is not very difficult to actually track the transaction back to an individual. It can be done. That's the point. Now, there is a whole ecosystem that revolves around blockchain. You have the cryptocurrencies, which is one of the most famous use cases of blockchain. And it is still probably the biggest one. You have Bitcoin, you have Ethereum, you have Ripple, you have Cardano, and hundreds of other cryptocurrencies, pretty much a few of them popping up every now and then. And then you have something called as centralized crypto exchanges. When you have these currencies in picture, you have to have a place wherein you can go and trade these currencies with other people. So centralized crypto exchanges provide the platform for people to go there and trade the cryptocurrencies, exchange cryptocurrencies with other cryptocurrencies, deposit their fiat currencies like US dollar, Australian dollar, and get an equivalent amount of a particular cryptocurrency in their wallets. Now, there are decentralized exchanges as well. I mean, the difference between decentralized exchanges and centralized exchanges, again, I mean, decentralized is something that is owned by an organization or a company, and a decentralized exchange is basically maintained by a group of peers or by the public. So inherently, they're more safer, and you don't have to rely on somebody. You don't have to trust somebody. And then you have these other things called as, you have these other things in this ecosystem like DeFi, Decentralized Finance. It has been one of the hot topics these days. You have non-fungible tokens, NFTs. You have the possibility of having an internet that is called Web 3.0. You have possibilities of technologies like interplanetary file system or peer-to-peer telecom networks coming into picture. I mean, this is a huge ecosystem. It's every month or two, there is some new technology or concept coming out to the market that basically inherits the basic features from the decentralized nature of blockchain. Now, apart from these, if you look at the development side of things, you have got a number of different integrated development environment and tools developed around this ecosystem. You've got a number of different programming languages like Solidity, Golang, client and contract SDKs developed, and a number of online editors as well, like Remix, for example. I mean, if you want to play with smart contracts, for example, you can straight away go and try that out within a few hours without having to install anything from scratch. And then in this ecosystem, there are other entities, like you have a very important thing called a crypto wallet, which is basically essential in order to deal with a blockchain network. And you have some hardwares as well in picture. I mean, when you learn more about Bitcoin in the discussion, you'll see something that is called ASIC that miners use to basically establish the consensus in a Bitcoin network. ASICs are basically hardware designed specifically for the purpose of mining Bitcoins. So, I mean, the ecosystem is not limited to these things. There are a lot more. There's a lot more to it. But in today's discussion, we are going to cover a few of them. We're going to touch a few of them. Now, this ecosystem naturally comes with opportunities. And from the things that we discussed in the previous slide, I've basically picked up a few of them that I think are one of the hot things to talk about these days. Number one is crypto. I mean, pretty much everybody knows what crypto is. You have Bitcoin, Ethereum, Ripple, Cardano, a number of different cryptocurrencies. People have exchanges wherein they can trade a number of different exchanges. And most of them are like cross-border. If you belong to a particular country, you can create an account in any exchange. And many of these exchanges are like KYC. At this point, KYC immune. In future, they might become KYC. They may have to do KYC, like what happened to Binance in past. But that's how it is for now. Crypto still enjoys the position of being the biggest use case of blockchain. Now, apart from crypto, there are two other important things in this ecosystem of opportunities. And one of the most talked about things is DeFi, which is decentralized finance. We are going to have a detailed look at this in some time. And then we have something called as non-fungible tokens. Now, this non-fungible token is probably one of the newest things that came to the blockchain scene in the last 3 years or something like that. I mean, they existed much before that. They have been in existence since early 2015, but it is in the last 2 or 3 years that people have basically started paying a lot more attention to them. And it is a topic that is a little difficult to understand because I mean, you have to visualize how you would articulate your real world assets, non-tangible assets in a digital world. Now, apart from these three, there is something called as enterprise blockchain landscape. Now, Bitcoin came into existence. It brought with us some technologies that were promising a lot of things for enterprises too, in terms of immutability of data, for example, and hashing. So enterprises, like big organizations like IBM and SAP, they realize that there is a lot of potential in some of the aspects of these technologies. And as a result, what happened is somewhere around 2015, people started to talk about enterprise blockchain. And from there, we started seeing adoption inside the industry, as well as when people started interacting with blockchains, they started facing problems. And when they started facing problems, they started working towards solution towards them. And as a result, some enterprise blockchain tools and utility in a small ecosystem of enterprise blockchain technologies started developing from there. Now, apart from these four, I mean, there are two important entities that we need to discuss. One of them is wallet. Wallet is something that you must have in order to interact with the blockchain network. It is something that at the lowest level stores your public and private keys. Public and private key is something that is essential to the working of blockchain. There are no user IDs or passwords when you're acting in the blockchain network. You have to have your private key stored somewhere. So wallet is the place that stores your private key. There are different types of wallets. We are going to discuss that later in the discussion. And the other important entity is contract. Contract is something that gave That is the reason why enterprises started paying attention to blockchain in the first place. Otherwise, if you have a look at Bitcoin, plain Bitcoin blockchain, I mean, it doesn't have apart from basically solving the transactional problems, I mean, it cannot be customized a lot. And when enterprises come into picture, you start looking at things like customization, performance, scalability, and things like that. So automation is another important characteristic that organizations look when they want to adopt a new technology or a system. And smart contract is something that basically gives you that option. We're going to discuss this about in detail in the ongoing discussion. Now, before we move forward, let us have a little bit. Have a look at a little bit of history. Now, Bitcoin came into existence right after the financial crisis of 2008. There was a white paper published by a team, apparently a team or under a pseudonym. And that paper described a solution to a problem that wasn't possible to solve before that point. Now, what people don't realize is that, I mean, when somebody is going and trying to understand about blockchain, many of the people consider that many of these technologies are something that Bitcoin introduced, like hashing or the usage of a private key to sign your transactions and a chain of blocks. But it is not true. I mean, Bitcoin was not the first attempt when Bitcoin was not the first attempt to solving this problem of a digital cash. At least 3 earlier attempts were made. There was something called as a system called as Hashcash. There was a system in the late 90s called as Bitgold. And most of these systems employed PKI, public key infrastructure, which is basically inside the core layer of Bitcoin, critical to the functioning of Bitcoin, public key infrastructure. They also had hashing involved, and they also had chain of blocks. Chain of blocks is something that was proposed first time in the year 1991. So what is it that made Bitcoin possible in 2008? It is something that people fail to realize. And it is basically the solution to a problem we call as in the blockchain landscape, we call it as double spend problem. When the same money that is stored in a digital cash system, digital cash ledger, is spent twice by a bad player. And Bitcoin was the first system to basically solve this problem. And in order to solve this problem, the innovation was the invention of mining, which is basically proof of work, the consensus algorithm that sits at the core of Bitcoin. Now, proof of work is a vast topic again. I mean, it involves a lot of mathematics in it. I would try to simplify it. I mean, we have to basically understand it in a couple of minutes, right? So it is, I mean, in plain English, it means what happens whenever a new transaction enters a system. There is this group of thousands of computers, and a kind of a cryptographic puzzle is given to them. They all try to solve that puzzle with the help of custom software installed on them and hardware as well. And the first of those computer systems that is going to solve this problem is going to be announced the winner, and that is going to broadcast, that is going to create the block from all the transactions that are inside that block. One block would have multiple transactions in it. It would create a block, and then it would broadcast that block to all the different competitors who are involved in that network. And those people would verify that block in one mathematical step, and they would agree. If it is valid, they would agree that, okay, this is the miner who was able to win this competition. And that block would be written to the blockchain, and it would be linked with the older chain with the help of a field called as previous hash, which is basically making Bitcoin stronger as the blockchain is growing larger. So this is where the immutability things comes from. I mean, you have these hashes into picture. Now, proof of work is the central mechanism with the help of which Bitcoin was able to solve the double spend problem. The signing of transaction was there earlier. The hashing was there earlier. People tried chaining of blocks as well in past. It was proof of work. And this was the invention, this was the innovation. And also the integration of all these technologies from past. It was one of the things that Bitcoin was able to do. Now, proof of work, there is a problem associated with proof of work because we have so many different computers competing with each other. And because there is something called as a difficulty level increase as blockchain grows. The problem is the next time these computers are going to solve the problem, the puzzle, they're going to take more CPU. And that would mean they're going to take more resources, more energy. And as a result, proof of work has proved to be a very expensive algorithm for establishing consensus in terms of energy. And I'm pretty much sure you're all aware of that. And that is one of the things that kind of look unattractive to the enterprises involved. And as a result, this gave birth to a number of different consensus algorithms in the landscape. One of them is proof of stake that Ethereum is planning to move in the next few months or next couple of years, in which basically you've got these stakeholders in the system who take care of establishing consensus. And then there's another algorithm called as Byzantine fault tolerance, practical Byzantine fault tolerance, which is basically a solution to a mathematical problem called Byzantine's general that was introduced in the 80s. So PBFT is one of the algorithms that is of specific interest to the enterprises in terms of implementing blockchain, because I mean, they cannot afford to have proof of work in place because it's going to consume a lot of energy. Now, we discussed some of the important entities in the blockchain landscape, the ecosystem. Decentralized finance is one of them. Now, in order to understand this, you have to basically ask yourself what Bitcoin is. Bitcoin is a currency. It's a decentralized currency. And what that means is you can send a fixed amount of this currency from person A to person B without the involvement of a central authority like a bank or a financial institution. Now, the problem is, in a true sense, financial system, it does not offer this service alone. I mean, this is a very simple scenario, sending money from person A to person B. A typical financial system, like our own centralized financial system, offers a number of different services apart from the simple transfer of money from one person to the other. They include insurance, they include credits, they include loans, they include, I think, saving plans and some retirement plans as well. So the objective of decentralized finance is to establish a system wherein these financial services offered to individuals or organizations without the need to have an intermediary or middleman in place, as opposed to our current financial system that is completely centralized in nature. So the way we call it decentralized finance, DeFi, we call our financial system CeFi, centralized financial system. Now, in order to do that, in order to achieve these features, in order to provide these features to the users, it's not that straightforward. You need to have a decentralized software and hardware infrastructure in place. You need to have a platform that allows you to basically write services or computer programs or application programs or smart contracts, as we call them, that would basically mimic the human actions that are taken by the centralized finance. These smart contracts are going to provide us the services. Now, if we have a look at the building blocks of a DeFi, what do we need? There are two important elements to it. Number one is the platform. In terms of platform, we have Ethereum. Ethereum is already a vast platform with a number of different tools around it, a big ecosystem of utilities, application programs, client applications supporting it. So you have Ethereum in place. That solves your first problem. Second problem is that in order to offer services in this system that deal with cash, you need some kind of currency. Now, a natural response from most of us would be, okay, we're going to use Bitcoin. So what? But there's a problem with Bitcoin and Ethereum as well, for that matter. Both of these are extremely volatile. The price of Bitcoin that is now can be very different from what it is after 5 minutes or after a day. So that's a problem. It's not a feasible solution. So the second important building block of a DeFi capability has to be some kind of a stable medium of exchange that doesn't change a lot with time. So that's where the concept of stable coins come into picture. Now, when I say stable coins, I mean, most of you who have already dealt with the cryptocurrencies in past know that there's something called as USD Ether. That was probably the first one. Now, in this context, in the context of DeFi, we don't prefer using USD Ether because of some kind of a possibility of fraud happening on the back of it. That's an altogether different story. We're not going to discuss that. There's a stable coin called as DAI, that we consider using for a DeFi app. And that's how many of the application developers develop DeFi. So basically, you have the first problem solved with the use of Ethereum network. You have the second problem solved with the help of DAI stablecoins. And with the help of these two, you can write smart contracts that would be dealing in terms of DAI, in which it would be able to offer services to the users. The users can get loans, the user can get credits, the user can get insurance. And in fact, there are some companies, some organizations that are already offering these services. Everything is written inside the smart contract, and you don't have to basically depend on a bank for doing that for you. And the benefits it offers is that, first of all, you don't have to trust a bank. Secondly, it is going to have a drastic effect on the transaction fees involved because you have application programs doing the things. But there are some cons to it as well. I mean, this technology is like very new. People have just started visualizing what it would be in the next few years. So I mean, in its early stages, there may be bugs in your smart contracts, right? And there are hackers waiting for your application development team to leave some kind of loopholes in the smart contracts that they can exploit. So basically, in a nutshell, decentralized finance is basically the idea of replacing our current centralized financial system with a decentralized infrastructure. And Ethereum is taking the lead in that direction. Now let's move on to the next topic, non-fungible tokens. Now, this is a little difficult to understand. I mean, there are specific types of assets that can be dealt with in this scenario. I mean, in order to understand this, we have to first of all understand what a fungible asset is and what a non-fungible asset is. Now, a fungible asset would be cash or gold. And what it means is that if you have $10 of bill with you, you can replace it with somebody's $10 bill, and the value will be retained. It won't be changed. Same applies to gold. But in case of, for example, a house or a piece of art, if you exchange your house with somebody else's house, there is always a possibility that there is a lot of difference in the values between the two of them. So each house has a unique value of its own, and that gives birth to the need of maintaining this asset as a unique asset in the blockchain. Now, this system would inherit its feature from the blockchain decentralization. So it would basically benefit from all those things like decentralization, immutability, single source of truth. On top of that, what non-fungible tokens have been able to achieve is that they would create a token that only has one copy of it in existence. That is the thing that NFTs offer. And that one copy cannot be duplicated. I mean, in the normal sense of it, it cannot be duplicated. Now, what do we use it for generally? I mean, these days it is being widely used for selling piece of arts like paintings, like your idea that could potentially result in a patent. And one of the biggest transactions that happened recently on an NFT using an NFT token was about 160,000, I think, in 2019, and we might see many more in the coming days and years. Now, there's one important consideration here. All the other Ethereum tokens, I mean, the normal Ethereum token is based on a protocol called as ERC20. And in order to be able to use non-fungible tokens, NFTs, we have to basically utilize ERC71 and ERC1151 protocols of Ethereum. One of them basically allows us to create only an NFT kind of a token, and the other one allows us to create both NFT and non-NFT kind of tokens. I hope that makes sense. I mean, this is a little difficult topic to understand. Now, there are risks associated with this technology. I mean, it's a new technology, and current exchanges that are in place are kind of very new. I mean, very immature in terms of dealing with this technology. And if you have a look at some of the examples, you have Decentraland, that is a virtual platform in which you can buy virtual assets like land or houses. You have a number of different NFT marketplaces like OpenSea, Foundation, Nifty Gateway, Rarible. And there is a proposal in place to have a system analogous to domain name system, which might be called Ethereum name system, that is basically going to utilize some kind of NFT in that as well. NFTs do have some applications in DeFi as well. I mean, in DeFi, there is a term called as yield farming, in which people stake their Ethereum holdings in order to give loans to people. And for that, you need to have some kind of collateral behind the scenes. So it is being proposed that NFTs are used as collaterals in DeFi networks. This mechanism is going to have some advantages as well as disadvantages. Anyway, let's move forward. So Web3 is basically, again, a technology coming out from the idea of decentralized systems. You have your current internet, which is based on Web2, which basically this is controlled by the internet providers, organizations, and websites and things like that. I mean, you have to trust them, and whenever they want, they can censor you and try to regulate you, and things like that, right? So Web3 is the idea of having an internet that is free for anybody to join, to use, and to post their content on, without the fear of being regulated or banned by any of these parties involved. And then Web3 is going to utilize a number of different technologies in order for it to function. One of the major ones is IPFS, Interplanetary File System, which is basically a file system that is based on distributed file systems, wherein you can shard individual files into different nodes. I don't know how that would be done. I mean, it's a very complicated technology, but that is going to be sitting at the core of Web3. And then there's another buzzword coming out of Web3, which is P2P telecom, which is basically allowing the mobile devices to communicate with each other without having the need to go to a telecom antenna or a service provider. I mean, a completely P2P based telecom network. So Web3 is going to involve these things. Now, some of these technologies already exist, but there are a lot of hurdles in terms of regulation and approvals from government and all. So, I mean, these things are not going to be apparent in the immediate future. It will gradually happen. The system will slowly integrate different technologies. And if this becomes a possibility, we still have to spend a few years before we see it being realized. Now, smart contract, as I just went through this topic. I mean, this is the automated guy who does the job for us in terms of DeFi, for example, and in terms of enterprise blockchain. This is basically the application that sits in the middle of the blockchain platform that we're using, whether it's Ethereum, whether it's Hyperledger or anything else. And it basically automates a lot of operational tasks in terms of transacting with the other business parties. Now, in terms of the technologies that we have available to us, Ethereum uses Solidity, but it has started developing a lot of SDKs for Go and Java and JavaScript as well. And in the same manner, Hyperledger has a very wide framework of SDKs and supported programming languages that it allows. And basically, it depends on the platform, what kind of programming languages and tools you're going to use. But there are some fixed ones out there. For example, Go is pretty much everywhere. I mean, Go and Node are pretty much everywhere in all the smart contracts. So you could write, if you use Go or Node, if you know any of these, you could go ahead and write smart contracts. Smart contract is the piece of blockchain that our web apps interact with. So when we send data, we record that onto the database called blockchain. It is basically the smart contract who's going to deal with us most of the times. Now, there's this thing called as digital wallet. If you want to act in the blockchain network, if you want to participate in the blockchain network, you have to have a digital wallet. The first of its kind was Bitcoin Core. I'm sure, people who know Bitcoin from the days of its inception would know what Bitcoin Core is. It's not a very popular wallet these days. There are third-party wallets that people tend to use. But broadly talking, if you broadly categorize wallets into three, then we would have software wallets, we would have hardware wallets, we would have paper wallets. Paper wallets are nothing but you could write down your own private key or use an offline utility to generate a private key and basically take a print out of it and remember it. And you could use that to transact with the Bitcoin network, for example, using some kind of client like command line. And then you have this thing called as hardware wallet, which is basically probably the safest of them all. In terms of security, all you have to do is basically plug in your USB. It's a USB kind of a thing that you have to plug into your system. It has a private key inside it, and it cannot be copied out of it. It gives you the option to basically recover your device in case you forget your passwords that you have to set when you initially set up this device. And then you have these software wallets. Basically Bitcoin Core, Electrum, Legend. Bitcoin Core and Electrum are basically the software wallets that people use, to deal with blockchains. There are some limitations to software wallets. In terms of security, they are not as secure as hardware wallets are because, there is always a possibility of somebody hacking. But they're still in wide use because the hardware wallet, in terms of cost, they're costly, they're expensive things, right? And and their compatibility is another problem. So, in a nutshell, digital wallet is the thing that you would need. It's the client application that you're going to use when you're going to deal with the blockchain network. Now, in terms of industry adoption, if we look at the map of things that have happened in the last 5 to 6 years alone, we see a number of different use cases being implemented in different industries. We have Ligon, which was a consortium created by Commonwealth Bank, Westpac, NZ Bank, Center Group, and IBM. And it recorded the first digital banking guarantee on its blockchain platform earlier this year. And this is something that happened in Australia. We should all be aware of this. Now, AdPay is something which is very similar to Afterpay, but it is entirely crypto-based. Afterpay, we all know Afterpay services, right? They have a proposal ongoing in which they're planning to move their payments to one of the widely used cryptocurrencies like Cardano or Ethereum or Ripple. So basically, they're looking at some cost benefits. There are some fees involved in the current transaction scenario. And then you have Power Ledger. You have a number of different organizations all across Australia, but dealing with different industry segments in terms of blockchain. Now, if you talk in terms of international projects, you have TradeLens. It's an open and neutral supply chain platform underpinned by blockchain technology. It was built by IBM in collaboration with Maersk. You have Food Trust Blockchain, which is an entire system built by IBM in which you could basically track the items that you're eating on a dinner table, for example, which farm it came from. and you can basically track it back to its form and the technology that was used to basically manufacture that. And there are different applications revolving around this use case. You have the food sector as well as the pharmaceutical sector basically have already implemented some different forms of cold chain in which basically they have IoT sensors put inside their vehicles. This is already being used during COVID. You have IoT sensors being fitted inside vehicles, and if the temperature goes wrong, these vaccines, if the temperature crosses above a specific threshold, these vaccines would be destroyed. So there is a need for the buyer to know whether these vaccines are good or not. I mean, whether they cross the temperature while on the way. So the IoT sensor is basically is going to write the data onto a blockchain network. And because there are multiple parties involved, like logistics provider, the manufacturer, the distributor, the retailer, and the consumer, I mean, all these are different parties. So an existence of a blockchain network between them is basically guarantees that the data is not messed up with. Now, this IBM and SAP joint venture accounting was a project that we built in 2018. I was a part of this team, and we served the oil and gas industry. And we basically automated the verification and posting of JIBs, joint interest billing, on IBM blockchain, as well as SAP blockchain. Now, opportunities for Australia. I mean, Australia has shown global leadership in terms of blockchain governance. And there is a relatively strong institutional infrastructure around incubating blockchain as a technology and basically reaping the benefits out of it later on. In terms of research as well, I mean, we've got organizations who have basically been involved with the blockchain since 2008 or 2009. I mean, one of the things that make the Australian landscape special is basically the strong financial services industry that was largely unaffected by the 2008 financial crisis. So basically, different sectors in Australia are looking at employing blockchain for different kind of use cases that are coming out of the features it offers to us. Now, this is one of the important considerations now. When businesses want to employ blockchain to solve some kind of problems, they have to look for a right fit. I mean, you can't solve everything with blockchain. There is something called as a fits assessment framework, in which we basically look at 4 broad factors. And some of them are like, if you have a business network in which you have multiple parties involved, if you have a business network in which there is a possibility of frauds, if you have a business network in which you cannot trust the other parties, there's conflict of interest. And if there's a business network in which, because of these conflicts, settlements may be delayed, these are basically typically the use cases that blockchain would be able to solve if you implement them the right way. So, I mean, FITS framework is not limited to just the points that I've listed on the slide. It is a little more to it than this, but this is basically broadly what it means. I mean, middlemen, frauds. If you're spending a lot of money on audits, if you're working in a trustless environment, this is when you need a blockchain kind of a solution. Excuse me. Now, in terms of blockchains, there are a number of different ways of classifying blockchains. You can do with a number of tools. For example, you can differentiate between blockchain with the help of consensus algorithms that they use. Many of them use very different algorithms, but I mean, I just tried following one of the ways here. I mean, it is based on the thing called as permission that you need to take when you're going to join the network. So public, private, and consortium are 3 different kind of blockchains. In case of public blockchain, in order to understand this, you have to take the example of Bitcoin or Ethereum. You don't have to take anybody's permission for taking part in Bitcoin and Ethereum. So they are public blockchains. In case of private blockchains, the private blockchain, although it would be limited, decentralized in nature, but it would mostly be controlled by 1 or 2 parties. And if you want to take part in that blockchain, you have to basically be a part of that network. You have to take that permission. Now, consortium is a little different. I mean, it is a middle path between public and private. It is basically a group of people, just the way we discussed with Ligon on the previous slide. It's a group of organizations or people that come together to form a blockchain network, and all of these have rights to grant access to their parties, their related entities to join the network. Now, there are some pros and cons of each one of these types of blockchain. Now, blockchain in enterprise adoption is, as you all see, whenever there's a Bitcoin bull run in picture, the speed of blockchain adoption increases because of the qualities it exhibits. Now, in the Forbes Blockchain 50 list, there are more than 50 organizations already. I mean, this World Blockchain list belongs to the 2019 survey, and if I remember correctly, most of these 40 or 50 organizations were more than 1 billion market cap organizations. So they basically have some kind of blockchain use cases running for them. They have some kind of blockchain applications being developed. Now, these enterprises, when they adopt technology like blockchain, they have to basically consider a few factors. For example, you can't waste a lot of energy for doing something like consensus, which Bitcoin does. Enterprises cannot do that because the volume of transaction within an enterprise network is much more than a public network because of all the different auditing and recording requirements. And then these enterprises wouldn't want that blockchain, for example, to be public. I mean, if they're running a blockchain network, they would want it to have a limited visibility. Common public shouldn't be able to see it. I mean, transparency, again, is related to it being public or private. I mean, you wouldn't want, enterprises wouldn't want their blockchain to be 100% transparent. I mean, number of different things. I mean, there are suppliers and manufacturers involved in the network, for example, and the manufacturers don't want to reveal their prices they offer to a particular supplier, right? So if things become transparent 100%, then there could be a competition between the suppliers. And then whether your blockchain is going to be a public or a private blockchain, it depends on what kind of a business model this use case is trying to solve. Like, is it going to serve directly the customers, or is it going to serve businesses? Now, in terms of performance, we all know proof of work is like, it's very slow. It is very difficult to scale. So enterprises would look for alternate mechanism like PBFT, for example, in order to implement blockchain at their side. Now, because of this, we can easily see one thing, that enterprises want customization, and Ethereum and Bitcoin don't provide customization. And now we have a need of, and as a result of that, we have a need of some kind of enterprise blockchain framework. And that problem is solved by some of the frameworks that are available in today's blockchain landscape. And one of the most famous is Hyperledger Fabric. And the other one is Coda. There is Ethereum Enterprise, that is again based on Ethereum Classic. And then we have Quorum, that again comes from Ethereum. Now, Hyperledger Fabric is one of the top scorer in this domain because of its modular nature. I mean, it has got this plug and play kind of features that it offers to organization, so they can basically plug in, for example, before setting up a network, they can choose what particular consensus algorithm they're going to choose. If they want to choose Raft, if they want to choose PBFT, or if they want to choose some kind of delegated proof of stake, right? They can do it at the time of configuration, and they can even change it later on after the system has run for a few years. So, I mean, these enterprise blockchain frameworks, especially Hyperledger Fabric, offers them the option to be flexible in terms of their implementation. Now, in terms of the comparison, Hyperledger Fabric was originally introduced for cross-industry use cases. It wasn't targeted towards a particular industry. And if we see the other three on this table, Quorum, Coda, and Ethereum, they were all concentrated on fintech mostly, financial use cases. But later on, I think Coda has also developed its portfolio, and I think now they have started supporting cross-industry use cases as well, apart from the initial financial use cases that they were looking at. Now, Coda and Hyperledger Fabric both are pluggable in terms of they allow a lot of flexibility in terms of what particular components organizations want to install in their blockchain networks. Now, a little bit of history of Hyperledger Fabric. It came into existence in 2016. Basically, 60% of the code base was contributed by IBM and an organization called Digital Asset. And by around 2017, we had a production blockchain service running, which was probably the first production-grade blockchain service that was launched by IBM in March of 2017. And since then, this space has grown a lot. I mean, we've been seeing a number of different players launching their Hyperledger Fabric services like Microsoft, Oracle, and Amazon. Now, in terms of Fabric architecture, I mean, this is a little bit of an old diagram that I used. It doesn't list down all the components. So in terms of Hyperledger Fabric blockchain, if we want to understand the different components, we have a certificate authority, we have a membership service provider that basically the certificate authority is responsible for generating certificates, private keys, and public keys. Membership service provider's job is to assign roles within the network. Orderer's job is to basically achieve consensus. Peer nodes are individual peers or nodes, the workhorse of the system. And there's something called as channel in this Hyperledger Fabric architecture. Now, this channel thing is something that addresses the privacy problem, the privacy concern of the enterprises. I mean, enterprises don't want all of their data to be public to all the participants. And that's where channel comes into the picture. Yes?
I'm sorry, we are 1 minute to go to the end of the session. There is one question. I don't know if you want to take that before we end the session.
Okay, let me go through it quickly then. Yep, so basically a channel is something that offers privacy to all the participants in the system, right? Now we have chain code. Chain code is basically nothing but the smart contract. Ledger is the database, and world state is basically is a point in time on that ledger that the smart contract deals with. Let me skip a couple of slides. Now, what I've done here is that I have created, I've basically provided a few steps for the developers on this call to get themselves started with the Hyperledger Fabric as well as Ethereum dApps. Now, it heavily depends on the platform. I mean, I basically, after the session, I would basically get in touch with the organizers and would put this information on a shared folder or a drive so that you could access this. So how I would go about it is that I would first of all try setting up I think Ethereum Hello World and Hyperledger Fabric, the last line. Yeah, these two are the ones which should be the normal starting point for all the developers out there. And once you start developing smart contracts on these, you will basically start to understand the things that we discussed in this discussion from a better angle. I think, Rosina, I think we can probably wind it up here.
Yes, do you want me to read the question?
Yes, please, yeah.
Yes, it says, how does the system Web3 prevent the fraudulent activities like money laundering, terrorism, etc., from the government compliance perspective?
Could you repeat that?
Yes, how does this system Web3 prevent the fraudulent activities like money laundering, terrorism, etc., from a government compliance perspective?
Okay, so I mean, Web3 is an idea. It is not been realized, and quite naturally there would be obstacles to it. There are good things coming with it as well as bad things. So yes, I mean, in terms of how the government is going to deal with it, I think we have a bigger problem in picture in terms of Bitcoin, right? The government has to deal with Bitcoin first. So in the last 10 or 12 years, it hasn't been able to do that effectively. I mean, there's no regulation concrete regulation around Bitcoin. So that is the first point, I think, where the government would be concentrating at this point in time. Web3 is going to be, is going to be a thing of future. So, as and when it comes, we'll see how the government tackles with it. But yes, the concerns are genuine. There are problems. If you have a P2P telecom network, for example, anybody could call anybody, and there would be no accountability. The mobile devices could be misused for things like attacks, as you mentioned. Yeah, it's a possibility. Rosina, is there any other question?
No, we are at the time of the session, so I think we can wrap up.
Yeah, I'm sorry, I missed a couple of slides, but I think we basically covered 90% or more of the stuff that we wanted to discuss, right? And I want to be able to share these steps of setting up a blockchain network of their own for the developers, Rosina. So how do I do that? Do I need to publish these links to a Drive folder or something like that?
We will share the recording for the session, but not the slides.
Okay,